Inheritance is one of the core principles of object-oriented programming. In Java, it is implemented using the extends keyword. When a class extends another class, the child class inherits the accessible members of the parent class. This includes all public, protected, and package accessible fields and methods. These members become available in the child class as if they were declared there. However, private members are not inherited. They still exist within the parent class, but the child class cannot access them directly. Another important point is that constructors are never inherited. This is why a child class must call the parent constructor explicitly using super. In Java, in every class automatically extends java.lang.object even if you do not explicitly write extends object. Okay. As a result, all classes inherit common methods such as toString, equals, and hash code. Java also supports single inheritance for classes, meaning a class can only have one direct parent class. This design helps avoid complications such as the diamond problem found in some other languages. Okay, so if you see this code here, right, we have class animal string name void it and private void secret, and then class dog extends animal void bark. When dog extends animal, it receives everything that animal has, so two specific exceptions. Dog inherits name and eat automatically, and no extra code is needed. Dog can use them as if they were declared inside dog itself. The two things that are never inherited are private members and constructors. Secret is private to animal, and secret method is private to animal here in the code, and private means declaring class only. Secret method is private to animal. Private means the declaring class only. Dog cannot see it, cannot call it, cannot inherit it. It exists inside animal objects but is completely invisible to dog. Constructors are never inherited here. Okay, and dog does not get animal's constructor for free. If dog needs to call animal's constructor, it must do explicitly through super. We covered that in the constructor chaining section. Okay, and how do you use inherited members, right? Here we have dog d new dog, then d.eat and d.bark, right? So d.eat is inherited, it works fine, and d.bark is declared in dog. So d is a dog object, and eat method was declared in animal but inherited by dog. Calling d.eat method works perfectly, and bark method also was declared in dog itself, also works. From the caller's perspective, there is no difference between an inherited method and one declared directly in the class. D.secret would be a compiler error, not because secret is in a defined package or has a defined access level, but because private members simply do not transfer through inheritance at all. And you see dog animal object, right? So that is the inheritance chain. Every class extends object. So animal extends object, and then dog extends animal. So every class in Java implicitly extends java.lang.object class, and unless it is explicitly extends something else, this happens silently. You do not write it, Java adds it automatically. This is why every object in Java has methods like toString, equals, hash code. They are defined in object and inherited by every single class, all the way down to the chain. And down the chain, dog inherits animal and animal inherits object. So dog has access to everything from animal and everything from object, minus anything that is private at each level. Okay, single inheritance, and Java only allows one direct parent class. So like we discussed earlier, so dog extends animal, that is one parent. You cannot write extends animal, extends mammal, so that it will be a compile time error. So this is called single inheritance. Multiple inheritance of behavior through classes is not allowed in Java. The reason is the diamond problem. If two parent classes both define the same method, the compiler cannot determine which one the child should inherit. Java avoids this entirely by restricting classes to one parent. Okay, so method overriding the fullest rule set, right? So method overriding occurs when a child provides its own implementation of a method defined in the parent class. For a method to be a valid override, several rules must be followed. First, the method signature must match exactly. This means the method name and parameter list must be identical to those in the parent class. Second, the return type must be the same or a covariant type, meaning it can be a subtype of the parent method's return type. Okay, so another rule involves the access modifier. The child method must have an access level that is the same as or more permissive than the parent method. For example, if the parent method is public, the overridden method must be also public. You cannot reduce the visibility, such as changing a public method to protected or private, like that. Certain methods cannot be overwritten also, and like static methods belong to the class rather than the object, right? If a child class defines a static method with the same name, it is considered method hiding, not overriding. Similarly, final methods can also be cannot be overridden. Any attempt to override a final method results in a compile time error. And at the rate override annotation, it doesn't change how the program behaves, right? But it is very useful during development. If you mark a method with at the rate override and it does not actually override a parent method, perhaps due to a typo in the parameters, the compiler will immediately report an error. So if you look at the code, we have class animal, public animal, make sound, return this, and then class dog extends animal. And you have an override, public dog make sound. So here dog overrides make sound from animal. So let's check every rule. Same method name here, make sound, same parameter list, no parameters, access modifier, public in both, equal access, and return type animal in the parent and dog in the child. Dog is a subtype of animal. So this is a valid covariant return. The child narrows the return type to something more specific, right? So all rules are satisfied. This is a valid override. The at the rate override annotation confirms our intent to the compiler. If anything in the signature was wrong, a typo, mismatch parameter, the compiler would immediately flag it. And if you see the next one, class cat extends animal, right? So this is more restrictive access and it will lead to compile error. Class cat extends animal, protected animal makes sound, return this, right? So this will be a compiler error. Why? The parent declares make sound as public, cat tries to override it as protected. Protected is more restrictive than public. A smaller audience can access it. Java does not allow this. So the reasoning is based on polymorphism. If code calls make sound through an animal reference, it expects public access. If the actual object is a cat and cat's version is protected, that access suddenly fails. The child cannot make things harder for callers than the parent promised, right? So the rule is access can stay the same or become more permissive. It can never become more restrictive. Public to protected is always compile time error. Next one is cannot override a final method, right? We have a sparrow. So we have class bird, final void fly, and we have class sparrow extends bird. It is saying from void fly. So it is a compile time error. Why? Bird declares fly as final. The final keyword on a method means this implementation is logged. No subclass may replace it. Sparrow, it tries to override fly and gets a compile time error immediately. Final on a method is a deliberate decision by the class author, right? So they are saying these methods behavior must not change in subclasses. It guarantees consistency and predictability across the entire inheritance hierarchy. But note that the final on a method is different from final on a class. A final class cannot be extended at all. A class with a final method can still be extended and subclasses just cannot override that specific method. Okay, so the complete override rule set is that the same name and parameter list required. Same or covariant return type required. Narrower the fine, wider is not. Okay, same or more permissive access required. Cannot restrict. Not static. Static methods are hidden, not overridden. Not final. Final methods cannot be overridden at all. All 5 conditions must be satisfied simultaneously. If you miss any of them, then either the override will fail or a compiler time error will result. Okay.